Hello everyone, this is Dr. Khalil and you're watching Math Majlis with Dr. Khalil. In this video, I will take chapter 1, section 1.2, that is properties of real numbers. So here we discuss what are the properties of the real number. The first one is commutative property. What is commutative property? In simple words, it is like this. You change place, no change. For example, and remember here, before I explain to you the commutative property, and remember there are basically 4 operations in mathematics. What are they? One is plus, that is, we call it addition, or sum. Minus, we call it difference or subtraction. This is multiplication or the product. And the last one is the division, that is dividing. So addition, subtraction, multiplication, division are the 4 operations. Whenever I am talking about the properties of the real number, please remember I am talking for this and this only, that is for addition and multiplication, not for subtraction, not for division. So coming back to this, what I will be writing now, I am going to explain to you what is commutative property. Commutative property means change place, no change. For example, I have two numbers, A and B. And look at it, I have to do only two operations, either plus or multiplication. Let me add these two numbers, that is A plus B. I have taken A first, then I have taken B. That is first A and then second is B. So what I will do now, I will change the place. That is first B and then second A. That is I change the places. So when I change the places, there is no change. That means A plus B and B plus A are same. What are AB? Any real number. This is with respect to the addition. Let's talk about multiplication. I take two number, I multiply. So when I multiply, A is first, B is second. Now I change the place. That is B dot A. No change. That means A dot B, that is A multiplied with B or B multiplied with A are one and same. So these are the two commutative property. The first one is with plus, the second one with the multiplication. Not for minus, not for division. That means A minus B is not equal to B minus A. Remember, that means it is not true for minus. A divided by B is not equal to B divided by A. So it is only true for plus and multiplication, not for minus and not for division. Not only this, all the properties which I am going to explain in this section 1.2, it is only for plus and multiplication. Coming to the next, second one, associative. Let me put it in a very simple way. What is associative? In associative, you change group, no change. In the first, change place, no change. Here, change group, no change. So again, let me take first plus. I will take A, B, C, three numbers, not two numbers. For associative, always three number. I will tell you why. What I will do now, I will take plus. I have not made any group. Remember, for a group, you need two numbers. So what I will do now, I will make a group of A and B. That means A and B, I made one group, then added to C. So what I will do now, I will change the group. Change the group means A plus B plus C. Now, instead of AB, I change the group to BC. That means here on the left side, this side, AB I made one group. Then here I change the group. BC I made one group. When I change the group, the no change, that means equal. So this is called the associative property for plus. Exactly similar way for multiplication. I can take any group. Let me take the group BC here. Then I will change the group. So instead of BC, I will take the group of AB. See that A dot BC, one group. AB, I change the group. And remember, they are the same. So these are the two associative property. For associative property, we need three number. The reason is here, this is not a group. For a group, you need A plus B. When at least you need two number. This is not a group. It is only a what you call, I write it in the bracket, but it is not a group. Therefore, in the associative, you need three number. From that three number, make a group of two number. Then you change it. Then there is no change. That is called the associative property. Then we have distributive property. Let's say distributive property. Look at it. Commutative, there are two with two numbers. Associative, there are two with three number. Distributive, there is only one distributive law, but we take the multiplication and addition together. For example, I take A, B, and C. Then I multiply this, and then I take say A, B, C, three number, and I take both operation, multiplication and plus. First multiplication, second plus. So what happens in the distributive is that the A is distributed to B and C. Means A goes to B and A goes to C with multiplication. That is A dot B plus A dot C. Remember, if it is plus, then it is plus. If it is minus, the same thing. A dot B minus C. Then it is A dot B, and since it is minus, then it is minus. Then we have A dot C. So both are same except I change the sign. So they are called distributive property. Remember, the first multiplication, the second either plus or minus. But don't forget this. A plus B dot C. Here I have taken three number. First I have taken plus, then I have taken the multiplication. Remember, this is not distributive property. For a distributive property, you should have first multiplication and then plus. This is not distributive property. So this is number third, that is distributive property, and there is only one, either for plus or minus. Coming to the next one. There are two identities in real numbers. Remember this. There are two identities in the real number. What are they? One is 0 and another is 1. These are the two what you call numbers in the real number which are known as identity. Remember, 0 is for plus and 1 is for multiplication. I told you we are considering only two operations, plus and multiplication. 0 for plus, 1 for multiplication. That means this is called additive identity and this is called multiplicative identity. What is the property? I mean, what is the property of the identity? Why we call it, it is identity. The reason is here, you see, any number you take and you take identity. You see, I take identity 0 with plus, therefore I plus. You know that a plus 0 is a. That means no change in the number. When you add with identity, there is no change in the number. When there is no change in the number, it is called identity. Let's see this. A dot 1. You know that 1 I have taken, multiplication means I multiply. A dot 1 is A. That means the number, any real number multiplied with 1, you get the same number. Any number you add with 0, you get same number. So identities do not change the number. With addition 0, with multiplication 1. So these are called two identities or in real numbers. There are two inverses in real number. What are they? One is negatives and another is reciprocal. This is for what? This is for addition and this is for multiplication. So there are two inverses, which is negative of a number is inverse and that is for positive. I mean operation. Reciprocal of a number is inverse, that is for multiplication. Note, what the inverses does, the inverses always gives you identity. Remember this. The inverses always gives you the identity. For example, you have a number A, real number. Then I take the inverse of A, which is what? Negative. That is negative. Negative is for plus. So I will add, then A plus minus A is what? 0. You get identity. Another example. A real number. I take the reciprocal. Reciprocal means up comes down or down comes up. So reciprocal of A is 1 by A. So what I will do, this cancels, you get what? 1. You get identity. So this minus A is the inverse of A because it gives you 0. 1 by A is the inverse of A because it gives you 1. That is identity. So negatives are the inverses, reciprocals are the inverses. So with this we come to the next. So but before that I just want to give you the reciprocal, little discussion on that. Reciprocal. What is the reciprocal of A? It is 1 by A. What is the reciprocal of 1 by A? It is A because down, up becomes down, down becomes up. What is the reciprocal of A by B? It is B by A. You change the positions. So this is called reciprocals. So with all this background, let us do examples from section 1.2 on page number 18 in the lecture notes. 1.2 section exercises. Let's do examples 1 to 6 because these are all the same. I will read the question. In the following exercises, use the commutative property to rewrite the given expression. You're not finding the sum. You're not finding the multiplication. You are just rewriting the given statement in another way by using the commutative property. For example, 1, 8 plus 9 equal to dash. So here we are given two real number 8 and 9. 8 is in the first position, 9 is in the second position. I have to use the commutative property. Therefore, I will have to change the position. That means I write first 9 and then 8. So 8 plus 9 is equal to 9.8. So this is the answer. You don't add up this. 8 plus 9 equal to 17. If you are adding if you are adding, that means you are finding the sum. You are not asked to find the sum of this. You are asked to rewrite A plus 9 in another form using the commutative property. That means you just change the places. For example, number 4. Y plus 1 equal to dash. So first place is y. Please remember y. What is the difference between this? Is a particular real number 8 and 9. This is any real number. When I use the letter A, B, C, Z or any letter, that means it is any real number. Any real number plus 1. That means I will change the position. That means this is what the answer for question number 4. Question number 3. 8 bracket minus 12. So here we are given two real number 8 and minus 2. So here they multiply. When I don't write anything, that means it is multiplied. So in this case, the first number is 8, the second number is minus 12. I have to use the commutative property. I will change the place. That means minus 12 first and then 8 is the answer for this. So these are the some of the examples in the first set, that is example 1 to 6. Coming to the next set, example 7 to 12. Let me take number 7. 11 plus 9 plus 14 is equal to dash. Look at it. In these questions, that is 7 to 12, use the associative property to rewrite the given expression. So you rewrite this, don't add, rewrite this, but now don't use the commutative, associative. And you know that for the associative, we need three number. Number 1, 2. And out of 3, I had to make a group of 2. So here we have made the group of 11 and 9. So only I had to change the group because I am now using the associative property. So I keep 11 out and then I make a group of 11 and 14. So this is the answer for what you call question number 7, where I use the associative property. I did not add up anything. So I change the group. Number 9. 12.5.7. So here I have made a group of 12 and 5. I change the group. 12.5.7 is the answer. Number 11. -7 plus 9 plus 8. So what are the three numbers here? -7, 9 and 8. And -7 plus 9 is one group. I change the group. That means I keep -7 out. Then I will make a group of 9 and 8. So that is the answer for question number 11. So question number 13 to 18, you can do it. So later we will do it. I mean, the same similar question we will be doing later. Now I will go to question number 19 to 27. Examples 19 to 27. Let's say question number 19. 4x plus 8. So here in this question, that is from questions 19 to 27, in the following exercises, simplify using the distributive property. That means use the distributive property and simplify. So both are there. So first I will use the distributive property 4 dot x plus 8. That means here there is a dot, nothing is written. So 4 is distributed here to x and 8. That is 4 dot x plus 4 dot 8. So here, till here, I have used the distributive property. Now the next stage is I simplify this. If I want to simplify this, 4 into x is 4x, 8 into 4, it is 32. This is simplified, and here I have used the distributive property. There are two parts. Only distributive property means you stop here. If you are asked to do the simplification, you can do the rest next step. Let's take another example. Number 22. 7 times 3p minus 8. First, let me use the the distributive property. Here we have dot and 7 is distributed. That is 7 dot 3p. Because if it is minus, it is 7 dot 8. Look at it. Because it is minus, it is minus here. Then this is stop. That means I use the distributive property. The next step is simplify. Simplify means I can multiply this. It is 21p. It is 56. 7 into 8, 56. So that's the what you call simplified. Here we simplify. Here we use the distributive property. Looking into some more examples. Number 26. Minus 3a plus 11. We have a dot here. So minus 3 is distributed. Please remember, not just 3. It's the whole minus 3 is distributed. So minus 3 into a plus minus 3 into 11. Look at it. Here we have plus, therefore we have plus. And minus 3 as a whole is distributed. So here I have used the distributive property. Now I will simplify this. Minus 3a, it is minus 3a, minus 3, that is plus, minus 3 into this, it is minus 33. Now I open the bracket. Minus 3a plus into minus, minus 33. You know this rule. See, plus, how to open the, the brackets. How to open the bracket. Plus, minus, it is minus, minus, plus, it is minus, 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 it is plus. This is how we open the bracket. So if it is outside plus, inside negative, negative. Outside negative, inside plus, negative. Both are negative, then it is plus. So here we have a plus minus, therefore it is minus 33. That is the answer for this. Coming to the 27. Minus r plus 7. So actually when you look at this, we see only two numbers, but in fact there are three numbers. What are they? It is minus 1 dot r plus 7. So this minus 1 is distributed to both. What happens? Minus 1 into r plus minus 1 into 7. Look at it. We have a plus, therefore plus. Okay, here we have plus. Minus 1 into r, it is minus r, plus minus 1 into minus 1 into 7, minus 7. Open the bracket. So minus r plus into minus minus, it is the answer. So this is how, here I have written minus means it is minus 1 distributed, and then open the bracket. The answer is minus r minus 7. So that's the end of the questions 19 to 27. Now questions 28. 101 plus 0 is equal to 101. So what is the question is here? Whether each example is using identity property of addition or multiplication. You'll have to just tell whether in this statement we have used additive identity property of addition or identity property of multiplication. So here we have used identity of plus. Why? Because 101 is a number added to 0, no change in the number. Therefore, this is what you call identity of plus. Question number 29. Minus 9 dot 1 is equal to minus 9. You see, we have a number minus 9 multiplied with 1, then there is no change in the number. Therefore, this is identity for multiplication. So, this is, here we have used the identity property of multiplication. One extra question. Suppose if I write like this, 9 into minus 1 is equal to minus 9. So in this case, you are given a real number 9 multiplied with minus 1, and there is a change in the number. You see, 9 becomes minus 9. Here minus 9 becomes minus 9 only, no change. That's why it is identity for multiplication. But in this case, 9 into minus 1 is minus 9. 9 becomes minus 9. That means the number changed. Therefore, is it an identity? No. That is for multiplication. It is not. Another example. 101 plus 1 is equal to 102. You are given a number 101 added to 1, it gives you 102, which is not the same. So therefore, is it 1 is the identity? No, this is not identity for plus. So for identity, the number should not change. Let's do the next set of questions. Example 31 to 36. Let me do question number 31, that is 8. What is the question here? In the following exercises, find additive and multiplicative inverse. That means you are asked to find the additive inverse of 8 and multiplicative inverse of 8. You know that there are two inverses, one for plus, one for multiplication. That is additive inverse and multiplicative inverse of 8. What is the, for addition, we just change the sign. What is the sign of 8? It is plus, I change it, minus 8. I change the sign of that. Plus 8 for addition, inverse is minus 8. Why? Because 8 plus minus 8 is equal to 0. Additive identity. Now, what is the, what you call, inverse of 8 with respect to multiplication? I take the reciprocal. That means 8 up, I take it down to 1 by 8. Why is it? Because 8 into 1 by 8 is equal to 1. That is identity. That's why the two inverses are minus 8 and 1 by 8. 33 minus 17. What are the two inverses of minus 17? One with plus, another is with multiplication. Plus means minus of minus 17. That means I have to take the negative of this. So negative of minus 17, this. Open the bracket. It is plus 17. So I have to take the reciprocal of this. Reciprocal means 1 divided by minus 17. So minus 17, either you write up, down or before. It is the same. That means I can write this way. Same. Even I can write 1 by 17. All are same. So plus 17 is the inverse of minus 17 with plus. Minus 1 by 17 or minus 1 by 17, 1 by minus 17 is the inverse of minus 17 with respect to multiplication. You just see your minus 17 plus 17 is 0. Minus 17 into minus 1 by minus 17 is equal to 1. That's why. Let's see the question number 35. It is 7 by 12. So, for plus, for multiplication. For plus, I change only the sign. The sign of this is positive. So, therefore, I change only the sign. For multiplication, I change the position. That is 7 by 12 becomes 12 by 7. So, no change in the sign, only the positions are changed. Here, change in the sign, no change in the position. So, minus 7 by 12 is the inverse of this with respect to plus. 12 by 7 is the inverse of this with respect to multiplication. That's the end of the questions 31 to 36. Coming to the last set of questions, that is 37 to 42. For that, you need this properties of 0. The properties of 0. Number 1, multiply any real number with 0, you get 0. 2, 0 by any number is 0. Third, any number divided by 0 is not defined. That means it is not a real number, or simply you can write not defined. So these are the three properties of the real number. So multiply any real number with 0, answer is 0. 0 by any number is 0. Any number by 0 is not defined. Using these three properties, let us solve the last set of question, that is 37 to 42. Example 37 to 42. Let me take example number 37. 48.0. The answer is 0. 38. 0 divided by 11 by 12. 0 divided, 0 is up, so it is 0. The same thing, if I write like this, 11 by 12 divided by 0. Now 0 is divided, so the answer is not defined. So for question number 39, it is not defined. For question number 40, it is 0. For question number 41, it is not defined. For question number 42, 1 by 10 divided by 0. So this is the up and it is divided by 0. That means 1 by 10 divided by 0. So it is divided by 0. Therefore, it is not defined. So that's the end of chapter 1, section 1.2. Thank you one and all.